Hey guys, it is Campbell here. Today we are going to be picking up what we started yesterday. Today it's going to be on AP Calculus BC, question number 2 from the 2024 exam. Let's just go ahead and get started right away. We'll start on part A. So, question 2, a particle is moving along a curve in the xy plane. And has position x of t, comma y of t at time t seconds, where x of t and y of t are measured in centimeters. It is known that x prime of t equals 8t minus t squared, and y prime of t equals negative t plus the square root of t to the 1.2 plus 20. At time t equals 2 seconds, the particle is at 0.36. So part A says to find the speed of the particle at time t equals 2 seconds. Show the setup for your calculations. So remember that the speed of a particle in 2 dimensions is equal to the square root of the x velocity squared plus the y velocity squared, which means the speed when time is 2 is the square root of x prime of 2 squared plus y prime of 2 squared. And if you plug that into a calculator, you should get 12.305, or if you truncate, 12.304. Now, it does not ask you for this, but just in case, if you want to be safe, you could say that the answer is 12.304 centimeters per second, or that at time equals 2 seconds, the speed is 12.304 centimeters per second. It does not ask for the units. It does not ask, the time is obviously in the question. So you could just leave your answer as this, but if you want to be safe, then yes, you could say 12.304 centimeters per second at t equals 2 seconds. All right, moving into part B, find the total distance traveled by the particle over the time interval 0 to 2 inclusive. Show the setup for your calculations. So remember, when you are working with parametrics, right? The total distance traveled, or the arc length, over an interval is simply going to be the integral from the beginning to the end of that interval of the speed of whatever it is you're tracking. So in this case, it's the particle, which means it is just going to be this formula plugged into our integral. So it is the integral from 0 to 2, because it says total distance traveled on the time interval from 0 to 2. So the integral from 0 to 2 of the square root of x prime of t squared plus y prime of t squared dt. And then when you plug that into your calculator, you should get approximately 15.902. And I did mess up earlier. Remember that on Calc BC, most of your answers you will generally want to do approximately, because on a question, if you do write equals when it should be approximately, you will be docked a point for that. And so the total distance traveled by the particle is on this interval is going to be 15.902 or 15.901 if you truncate centimeters. All right, part C now says find the y-coordinate of the position of the particle at time t equals 0 and show the setup for your calculations. So we are given the y-coordinate at time t equals 2. Remember, right up here, it says that the y-coordinate is 6 at time t equals 2. So this is going to be a simple fundamental theorem question. We have the integral from 0 to 2 simply of y prime of t dt. Of course you can plug in the whole function for y prime, but this will give you just the same credit. You don't need to plug in the whole function since it has been, like we said yesterday, because it has been defined, you can simply put in y of t. And because this is fundamental theorem, we know that this is going to be equal to the y coordinate at 2 minus the y coordinate at 0. The integral from 0 to 2 of y prime of t is equal to 6 minus y of 0. And this integral, when you plug it into a calculator, is approximately equal to 7.1736. We want to keep more decimal places for this answer, so you may want to go out even further. And we know that that is going to be equal to 6 minus y of 0. And we know that y of 0 is now approximately equal to negative 1.173, or negative 1.174 if you want to round. Alright, now moving on to part D, we are told that for 2 to 8 inclusive, the particle remains in the first quadrant. Find all times t in the interval 2 to 8 inclusive when the particle is moving toward the x-axis. Give a reason for your answer. So we can go ahead and make ourselves a little drawing here. So we know that from t equals 2 to t equals 8, the particle remains in this first quadrant here. So we need to find all times t in that interval when the particle is moving toward the x-axis, meaning when the particle has a negative y velocity. So what this means is we are going to be using our y prime of t formula, and that again is negative t plus the square root of t to the 1.2 plus 20. So we want to know when this is less than 0. This is a question where a graphing calculator is required, so you can plug this whole function into your calculator and find that y prime of t equals 0 at t equals approximately 5.2218. And you'll probably notice a graph that looks something like this. And so before this time, your y velocity is positive. And after, it is negative. So because of this, the final answer to this question is going to be the particle moves towards the x-axis on the interval 5.221 or 5.222 to 8. Since the y value is positive and that is given, and the derivative of the y value is negative on the interval. So that's pretty much everything for question 2 on the 2024 AP Calculus BC exam. Pretty simple question. I mean, it's just knowing the math, doing the math in your calculator. Like I said, you do have to know the fundamental theorem. You do have to know the formulas for distance and arc length and speed in like parametric, or some of the exams will be in polar. So yeah, fairly standard question. Next time I'm going to be going over question 2 for the AP Calculus AB exam. So stay tuned for that. It's going to be going up later. If you found this video useful or enjoyable, please go ahead and leave a like and consider subscribing to see more videos like this. Let me know any topics that you guys would like covered, and I will see you next time. Bye.